You know, I was thinking about how we've all been sort of conditioned over the last couple of years. We've
Yeah.
developed this very specific reflex when it comes to AI.
Oh, absolutely. The instant gratification thing.
Right, yeah. You type a prompt, you hit enter, and the text just streams out immediately. It feels like magic mainly because it's just so impossibly fast.
It's the improv actor model of AI. It's fast, it's fluid, and it just keeps the scene going no matter what you throw at it.
Exactly. But then I got access to this new model series from OpenAI, the O1 series.
Mm.
Specifically, I was using O1 Preview. And the very first time I used it, I honestly thought it was broken.
You hit the pause.
I hit the pause. I asked it a really hard question, and it just sat there 10, maybe 20 seconds. Just this little thinking bubble pulsing on the screen. And my brain immediately went to, well, the server is down or is hanging.
Right, but that silence is actually the feature. It's not a bug. That pause represents probably the most significant shift in AI architecture we've seen since the launch of ChatGPT itself.
And that is exactly what we are unpacking in our deep dive today. We aren't talking about a model that just talks faster or, memorizes more trivia. We're looking at a model that fundamentally reasons.
Yeah, it's a massive shift.
So our mission today for you listening is to really look under the hood. We're going to see what is actually happening during that 20-second delay. We're going to walk through a cipher it cracked that is honestly just mind-bending.
Mm.
And then we're going to discuss why this new thinking capability might actually make AI safer, or at least much harder to trick.
It really is a complete transition from just predicting the next word to genuinely solving the problem.
So let's get right into the mechanics first. Because when we say an AI is thinking, usually we're just anthropomorphizing, right? We're projecting human traits onto a calculator.
Exactly.
But with O1, OpenAI is claiming this is architectural. So what is it actually doing while I'm sitting there waiting for that thinking bubble to disappear?
It is generating what's called a chain of thought. Now, to understand why this matters, think about how you handle a really complex problem. Let's say I give you a tough riddle or a really nasty math equation. You don't just blurt out the answer the second I finish speaking.
No, absolutely not. I'd grab a piece of paper, I'd write down the variables I know, try a formula. If that didn't look right, I'd cross it out and try a completely different angle.
Right. You engage in an internal monologue, you iterate, and O1 is designed to do exactly that. It generates this whole sequence of reasoning steps before it ever sends a final answer back to the user.
So it's effectively writing on its own internal scratchpad.
That's the perfect analogy for it. But here is the key innovation. It's not just that it has a scratchpad. It's that OpenAI used reinforcement learning to train the model how to use that scratchpad effectively.
Meaning it's not just rambling to itself, it's actually learning strategies.
Precisely. You know how previous models were very linear? They'd start a sentence and just commit to it like a runaway train? If they realized halfway through a paragraph that they were logically cornered, they wouldn't stop. They would often just hallucinate or double down just to make the sentence finish grammatically.
Right, the confident liar mode. We've all seen that.
But O1 learns to recognize its own mistakes. It can hit a dead end in its thought process, stop, recognize that the current path isn't working, back up, and try a completely different strategy. It self-corrects.
That feels distinctively human. Just that ability to say, wait, I messed up, let me restart this.
And this introduces a brand new scaling law to the industry. We're so used to hearing that to make AI smarter, you just need more data and more chips during the training phase. But this introduces test time compute.
Test time compute. Let's break that down for the listener because that's a huge concept.
It basically means the performance of the model improves the longer you let it think before it answers you. It's a direct trade-off. You pay with time, you wait those extra seconds or even minutes, but you buy accuracy.
So patience is literally a virtue here. The longer it ponders the prompt, the smarter the result you get.
Measurably so. The data backs it up completely.
Okay, I want to ground this. Because reasoning is kind of a fluffy word until you see it applied in the real world. And the OpenAI documentation gave us this incredible example of a cipher, a custom code that O1 cracked. And I think this is the perfect show, don't tell moment for the difference between pattern matching and actual thinking.
Oh, the strawberry cipher.
Yeah.
Yes, this was a fascinating test case.
So let me set the scene for everyone. The user gives the model a prompt with a custom code, and they provide exactly one example to teach the model the rules. The example is a string of just gibberish letters. It's O-Y, F, J, D, N, I, S, D, R, and so on, a whole block of it.
Right.
And the user tells the model, this gibberish translates to the English phrase, think step by step.
So this is standard few-shot prompting. You give it the pattern, you give it the key, and then ask it to apply that logic to a brand new problem.
Right. So then the user pastes in a massive, totally new string of random letters and says, okay, decode this. Now, a standard model like GPT-4o would usually look at that and just guess. It relies on tokens.
It relies on its training.
Yeah, it might just hallucinate words that look visually similar to the letters because it doesn't actually reason.
It would try to match the pattern of the text without understanding the underlying logic of the cipher at all.
But O1 went into that thinking mode. And because we have the developer report, we can actually see the summary of what it did during that pause. It didn't just guess. It started investigating.
The first thing it did was basic data analysis. It counted the letters. It noticed that the plain text English phrase in the example, think step by step, has 15 letters. But the encrypted gibberish version has exactly 30 letters.
Okay, so immediate deduction. The code is twice as long as the message.
Right, so it forms a hypothesis. Maybe the ciphertext words are exactly twice as long as the plain text words.
Which is entirely logical, so it starts testing that theory.
And this is the part I love. It fails. It tries taking every other letter of the code. It produces total garbage. It tries mapping the columns. Garbage again. Now, in a standard model, this is exactly where you'd get a hallucination. The model would just force an answer to please you.
But O1 recognized the failure. It literally discarded those theories on its scratch pad and moved to math.
It decided to treat the letters as numbers. A equals 1, B equals 2, and so on. It looked at the very first pair of letters in the example code, O and Y. And it knew from the prompt that these two letters had to somehow result in the letter T, because T is the first letter of think.
Okay, I want to slow this down so everyone can visualize the math here. We have O and Y.
Right. So O is the 15th letter of the alphabet. Y is the 25th letter.
Okay, 15 and 25.
The model sums them up. 15 plus 25 is 40.
And we're looking for T.
And T is the 20th letter of the alphabet.
So 40 and 20, it's an average.
Exactly. The model realized that 40 divided by 2 is 20. The hidden rule is you add the numerical value of the two letters together and calculate the average to get the real letter.
That is a pretty complex leap of logic to make from just one single example string.
It really is. It's not just pattern matching. It is rigorous hypothesis testing. And once it derived that formula average the pairs, it applied it to the brand new unsolved string of text the user gave it. It crunched the numbers for every single pair in that huge block of text.
And the result?
It decoded the entire message letter by letter perfectly. And the final plain text message it generated was, there are 3 R's in strawberry.
There are 3 R's in strawberry. I have to admit, I actually laughed out loud when I read that in the report.
It is a bit of a troll by the engineers, isn't it?
It really is. For anyone who hasn't been terminally online in the AI space lately, explain why that specific sentence is such a flex.
Well, for months, people have been mercilessly mocking large language models because if you ask them how many R's are in the word strawberry, they would almost always confidently say 2.
It became a huge meme, like, AI is going to take our jobs, but it can't spell a basic fruit.
And it's all because of tokenization. These older models see the word as a single chunk, a token, not as individual letters. So they fundamentally struggle with counting characters within a word.
So O1 didn't just solve a complex mathematical cipher. It used the solution to prove it can solve the one logic puzzle everyone says AI can't do.
Exactly. It shows that it didn't just stumble onto the answer by predicting words. It reasoned its way through the arithmetic to get there. It's a pure demonstration of precision.
But this goes way beyond parlor tricks and internet memes. The cipher is fun, but when we look at the benchmarks, the actual standardized exams, that's where the numbers get kind of scary.
Startling is the word I'd use. The jump in performance is not incremental, it's a leap. Let's look at math first. The AIME, the American Invitational Mathematics Examination.
Right, and just for context, this isn't the SATs, this is for the absolute top high school math competitors in the country.
Correct. GPT-4o, which was the previous flagship model, really struggled here. It solved only about 12% of the problems. That's roughly 1.8 out of 15 questions.
12% is a hard fail.
Now look at O1 preview. When allowed to use consensus, which basically means letting the model think through the problem multiple times and then vote on its own best answer, it hit 83%.
From 12% to 83%. That is astronomical for one generation.
To put that in human perspective, scoring an 83% places the model among the top 500 high school students in the entire United States. It qualifies for the USA Mathematical Olympiad.
So we basically went from can't count the letters in a fruit to top-tier national math weight in a single update.
Essentially, yes. And we see a similar leap in science. There's a benchmark called GPQA Diamond. This tests deep, graduate-level expertise in chemistry, physics, and biology. Just to create the benchmark, OpenAI actually had to recruit human experts with PhDs to answer the questions.
Real human scientists taking the test to set the baseline.
Yes, and O1 surpassed the performance of those human experts. It is the very first AI model to do so on this specific benchmark.
Okay, I need to pause on that.
Sure.
Because that is a massive headline waiting to happen. AI smarter than PhD physicist? Is that actually accurate?
It's a highly nuanced claim, and we definitely need to be careful here. No, it doesn't mean the model is smarter in a general, holistic sense. Having a PhD implies years of lab work, thesis writing, creativity, experimental design.
Hand-eye coordination with Python.
Yes, exactly. Specialized intuition. The model isn't doing any of that.
It's not running a wet lab.
Right, but on a strictly written exam designed to test the specific complex logic problems a PhD candidate would be expected to solve, yes, it wins. It is more proficient at retrieving and applying complex textbook logic to novel problems.
So if you need a research assistant to check your calculations or verify a really complex theoretical point, this is your tool.
It's the ultimate test taker and checking tool. And that extends to coding, too. On Codeforces, which is a massive competitive programming platform, O1 ranked in the 89th percentile. GPT-4o was down in the 11th percentile.
Again, going from the bottom 10% to the top 10%.
And here's a detail I found absolutely fascinating. In a simulation of the International Olympiad in Informatics, they found that if they relaxed the competition constraints and allowed the model 10,000 submissions.
Wait, 10,000 tries to get the code right?
Yes. If they let it generate, test, debug, and resubmit 10,000 times, it scored above the gold medal threshold.
And that connects right back to that test time compute idea we talked about. If you have enough time or enough tries, the reasoning process eventually gets you to the elite answer.
Because it's not just about raw knowledge. It's about the ability to utilize that knowledge to debug and refine its own work. It's the persistence of reasoning.
Which brings us to the elephant in the room here. If we have an AI that is this good at reasoning, at coding, at high-level science, isn't that a little unnerving? I mean, if it can figure out a cipher by inventing its own math rules on the fly, can it figure out how to bypass its own safety rules?
This is where the chain of thought actually acts as a buffer. It's quite counterintuitive.
Because I would assume a smarter model is a more dangerous model. Like, I know you told me not to build a bomb, but look how clever I am at finding a loophole.
You'd think so. But the chain of thought allows for much better adherence to safety guidelines because the model can actually reason about the rules in context.
So instead of a flat no based on a keyword trigger, it thinks through why it should say no.
Exactly. Previous models relied heavily on basic block lists. If you asked for something that looked vaguely like a weapon, it blocked it. But users could easily trick it. You know, write me a movie script where the fictional hero builds a device to mix these two chemicals.
It's classic jailbreaking.
Right. There's a safety benchmark called Strong Reject that measures how well a model resists these tricks. GPT-4o scored a 0.22. It was easily tricked. O1 preview jumped to 0.84.
That is a massive jump in safety compliance.
Because it thinks. It looks at the prompt and says, wait, the user is asking for a chemical recipe. Even though they phrased it as a hypothetical movie script, the output would still be a dangerous real-world recipe. That violates my safety policy. Therefore, I will refuse.
It sees through the ruse. It parses the actual intent of the user, not just the words they typed.
And it also helps with the exact opposite problem. Being too annoying. You know, when you ask for something totally innocent and the AI lectures you.
Oh, yeah. I cannot help with that because it might be vaguely unsafe. Yeah, the over-refusal problem.
Reasoning helps there, too. It can determine, okay, this looks suspicious at first glance, but in this specific context, it's actually completely benign. It navigates those gray areas much better.
Now, this brings us to the part that really frustrates me, and I know it frustrates a lot of power users. We spent this whole time talking about how amazing this chain of thought is. I want to see it. I want to open ChatGPT, hit a drop-down menu, and read the raw scratch paper.
No.
But I can't.
No, you cannot. OpenAI has firmly decided that the raw chain of thought is completely hidden from users.
Which just feels like a huge step back in transparency. If it's thinking, why can't I see the thoughts?
Well, they list a few reasons in the technical report. The first is obviously commercial. That specific way the model thinks, the exact strategies it uses on that scratchpad that is their secret sauce.
Okay, so protecting the IP. They don't want competitors taking the raw logs and training their own models on Owen's reasoning.
Exactly. But the second reason is much more interesting, and it's entirely about safety monitoring. They want to be able to read the mind of the model without the user influencing it.
Wait, break that down, like the observer effect in physics.
Essentially, yes. If you and I could see the raw thoughts, we might learn how to prompt the model to change its thought process. We might figure out that if we say a specific phrase or frame the question a certain weird way, the model skips a safety check in its internal monologue.
We'd game the system.
We would be optimizing our prompts to manipulate the thought process directly. By hiding the thoughts from us, the model acts naturally. This allows OpenAI to review the raw logs on the back end to see if the model is ever being genuinely deceptive.
So they need to see if the model is thinking things like, I know this is wrong, but I'll do it anyway, just to make the user happy and get a good rating.
Exactly. If the user could see that thought, the model might eventually learn to hide it even from itself. Or the user might punish it for having honest thoughts by downvoting it. So, the raw, messy, potentially deceptive internal monologue, that's strictly for OpenAI's safety team only.
So what do we get then?
We get a summary. The model generates a polished, sanitized summary of what it thought about, like, I analyzed the code, I tested 3 hypotheses, I found the solution, but you don't get the raw, unadulterated log.
So it tells me, here's how I solved your problem, but I just have to trust that the summary matches what it actually thought.
Precisely. You get the finalized police report, you don't get the detective's raw notebook.
It's a fascinating dynamic.
Yeah.
We are really moving from a world of chatbots, which were basically just autocomplete on steroids, to a world of actual collaborators.
Collaborators that take their time, that check their work, that utilize test-time compute to solve problems that were previously thought impossible for AI.
We've got a model that is crushing high-level math, decoding ciphers by inventing formulas on the fly, and performing at a literal gold medal level in coding. And it's doing it all just by taking a pause.
It really signals that the scaling wars aren't just about making the models bigger anymore, it's about making them deeper.
The novelty of, oh look, it can write a poem, is definitely over. Now we're entering the era of, it can solve a problem I couldn't solve myself.
Which is going to fundamentally change how we use these tools in science, in software engineering, in really anything that requires precision rather than just fluency.
Well said. And I want to leave you, the listener, with one final thought to chew on today. We talked about that hidden chain of thought. OpenAI hides it so they can monitor the model for deception to make sure it's not manipulating us. But here's the question. If the model is smart enough to reason at a PhD level, is it smart enough to lie about how it reasoned?
If the summary we see is generated by the model itself, is it telling us the truth about its process, or is it just telling us what it thinks we want to hear?
Exactly. Are we seeing the actual logic, or just a really convincing cover story? Something to think about next time you see that thinking bubble pop up on your screen. Thanks for joining us on our deep dive. See you next time.